Good evening, students. I am Sushil Kumar Tripathi from St. Xavier School, Pihani. Today we have to start part 2 of continuity and differentiability. Before starting this video, I would like to say you that if you will like my video, then please share and subscribe it. Now, in this video, we have to start from example number 1 and we have to see how we can solve the problems related to continuity. So, example number 1. Check the continuity of the function f given by f(x) is equal to 2x plus 3 at x equal to 1. F of x is equal to 2x plus 3 at x equal to 1. We have to find the value of the given function. For finding the value of given function at point x equal to 1, we can replace x in the given function by 1. So f of 1 is equal to 2 into 1 plus 3, that is 5. So fx is defined at x equal to 1. Whenever in any problem related to continuity of any function, first we have to see whether the given function is defined at that point or not. So we have calculated in this way. We have seen that given function f of x is equal to 2x plus 3 is defined at x equal to 1. Now we have to calculate left hand limit at x equal to 1. For this, we can write in this way: left hand limit is equal to limit of 2x plus 3 x tends to 1 minus is equal to limit h tend to 0, and we can replace x in the given function by 1 minus h, and after that we can calculate. So in this way we have to find the value of left hand limit as 5. After that we can calculate right hand limit. So right hand limit of 2x plus 3 when x tends to 1 plus. So we can replace x by 1 plus h and h tends to 0. So we can write in this way: limit of 2 into 1h plus 3 plus 3, 2 into 1 plus h plus 3 when h tends to 0. So in this way we can calculate the value of right hand limit at x tends to 1 is equal to 5. So we can see the value of f of 1 and left hand limit at x equal to 1 and right hand limit at x equal to 1. The value of all these were 3 at x equal to 1. So in this way we can say that the given function fx is equal to 2x plus 3 is continuous at x equal to 1. So in this way example number 1 completed. Now we can take example number 2. Examine whether the function f given by fx is equal to x square is continuous at x equal to 0. So first of all we can see whether the given function fx equal to x square is defined at the given point, means at x equal to 0. So we can calculate f of 0, it is 0. So we can say that fx equal to x square is defined at x equal to 0. Now we can calculate left hand limit of function at x equal to 0. So we can write left hand limit equal to limit of x square x tends to 0 minus. Now we can replace x by 0 minus h and write h tends to 0. So it will be limit of 0 minus h whole square h tends to 0. Limit of h square h tends to 0 is equal to 0. Now we can calculate right hand limit. Right hand limit means limit of x square when x tends to 0 plus. So we can replace x by 0 plus h in the given function. So it will be limit of h square when h tends to 0. It is also equal to 0. So we can say f of 0 is equal to left hand limit at x equal to 0 is equal to right hand limit at x equal to 0 is equal to 0 means we have got all the three values are 0. So we can say fx is continuous at x equal to 0. So in this way, we have completed example number 2. Now we can take next example, that is example number 3. Discuss the continuity of the function f given by f of x is equal to modulus of x at x equal to 0. So first we can see whether it is defined at x equal to 0 or not. So we can substitute x as 0. So f of x is equal to modulus of x at x equal to 0. So f of 0 is equal to modulus of 0 is equal to 0. So we can say fx is equal to modulus of x is defined at x equal to 0. Now we can calculate left hand limit. Left hand limit is equal to limit of modulus of x when x tends to 0 minus is equal to limit modulus of 0 minus h tends to 0 it is equal to limit of modulus of minus h when h tends to 0. Value of modulus of minus h will be h. So we can write limit of h tends to 0. We can put h equal to 0. So in this way left hand limit is equal to 0, or we can say the value of left hand limit is equal to 0. So we can find right hand limit. Limit of modulus of x tends to 0 plus is equal to limit modulus of 0 plus h tends to 0 is equal to limit of modulus of h tends to 0 is equal to limit of h tends to 0 is equal to 0. So we can, in this way we can see the value of f of 0 and left hand limit at x equal to 0 is equal to right hand limit at x equal to 0, and all these three values were equal to 0. So we can say that given function f of x is equal to modulus of x is continuous at x equal to 0. Now next example we can take, that is example number 4. Show that the function f given by f of x is equal to x cube plus 3 if x is not equal to 0, and when x is equal to 0 value of given function is equal to 1 is not continuous at x equal to 0. So in example number 1, 2 and 3 we have seen all were continuous, but in this example we can see how we can show that given function is not continuous. So first of all, we want to check at x equal to 0 discontinuity of the given function. So we can find the value of given function at 0, whether it is defined or not. Let us see. F of 0 is equal to 1. So we can say fx is defined at x equal to 0. Now we can calculate left hand limit at x equal to 0. So we can write limit of fx, x tends to 0 minus. We can substitute the value of fx when x is not equal to 0 means x cube plus 3. So limit of x cube plus 3 when x tends to 0 minus. Now we can replace x by 0 minus h. So limit of 0 minus h whole cube plus 3 upon, sorry, limit of 0 minus h whole cube plus 3 when h tends to 0. So it will be equal to 0 cube plus 3. So in this way the value of left hand limit is equal to 3. So we can say f of 0 was 1, but left hand limit is 3. So these two values are not equal to each other. So we can say f of 0 is not equal to left hand limit at x equal to 0. So we can say fx is not continuous at x equal to 0. Only this much is sufficient. We have no need to find right hand limit because f of 0 is not equal to left hand limit. Now we can take next example, that is example number 5. Check the points where the constant function fx equal to k is continuous. We know that constant function fx equal to k is defined for all real numbers. Always we have to keep in mind that constant function fx equal to k is defined for all real numbers. Let us take a real number c where fx is equal to k. So f of c is equal to k, also k. We can substitute x by c, value will be same as k. Now left hand limit. Left hand limit is equal to limit of fx x tends to c minus. So limit of k x tends to c minus. So we can write limit of k when h tends to 0 is equal to k. Now we can see what is the value of right hand limit. Right hand limit is equal to limit of fx x tends to c plus equal to limit of k x tends to c plus. So limit of k when h tends to 0 is equal to k. Now f of c is equal to left hand limit at x equal to c is equal to right hand limit at x equal to c. Therefore, fx is continuous for every real number. In this way, we can say fx is continuous for every real number. Thank you. This is the end of this video. In next video, we have to solve some other problems related to other examples related to continuity, other examples.